Today we're going to look at dividing whole numbers, and this is something you should have done before, but the way we do it today might be slightly different than how you've done it before. So I want you to look at our steps here. Our steps are to divide, multiply, subtract, check, bring down, and then repeat. So in other words, go back in, divide, multiply, subtract, check, and bring down again. And one way you can remember those steps is you can remember the phrase, does McDonald's sell cheeseburgers? And the first letter of each word in that would help you remember D for divide, M for multiply, S for subtract, C for check, and B for bring down. And so that's just a thought about how you can remember that. Now, a couple of things that we need to review about division is, one thing is the ways that we write division. So 4,992 divided by 8. If we wanted to write that, there are multiple ways we could write that. The way it's already written, obviously, is like this last way, 4,992 divided by 8. And in that, 4,992 is the dividend, 8 is the divisor. When I work it out and get an answer, that would be my quotient. We're going to primarily be writing it using a division house today. So when you write it like that, your dividend is 4,992, your divisor is 8, and your quotient, your answer, would go on top of the house. Now here's a little tip. I used to always forget which one was the dividend and which one was the divisor, but then I hear, when I sound out the word dividend, I hear N. I know it's not spelled I-N, but it sounds like that, dividend. The dividend is the number that's in the house. So you can remember dividend that way. And if you know that that one's the dividend, then the one on the outside must be the divisor. We can also write division in fraction form. That would be something like what the second way is, where we put the dividend over the divisor. So 4,992 divided by 8 could look like this. Now let's get to some actual division. Now, one thing I want to point out to you is, you might be wondering why I have these vertical lines here. It's because I want you to think about one of the really super important things in division is that we line up our problem correctly and carefully. And so one way that would help you do that is to have lines like this that would help you separate out different columns and keep everything lined up. And you may think, well, where am I ever going to do that? Well, think about a piece of notebook paper. If you turn it sideways, then your lines are vertical like that. And so you could solve your problem, turn your notebook paper sideways and solve your problems on notebook paper that way. And it would help you to keep everything lined up. Now, before we do that, I want to point out to you, some of you may have learned to divide using what's called the Big 7. I hear people call it the Big 7 before. And you might have learned to do something kind of like this. Say, well, and you've got your Big 7 over here, and say, well, 6, I can do 100 times 6, and 100 times 6 is 600. So let me subtract that from 1,248. And when I do that, I'm going to get 648. Well, 6 into 648, it can go 100 more times, because 100 times, I probably would put that 100 a little bit lower, I guess. 100 times 6 is 600. And so 648 minus 600 is 48. Well, 6 can go into 48 8 times. And 8 times 6 is 48, and there's nothing left. And so then you know to go back and do your add your numbers together, and you're going to get 208 as your answer. And that is the correct answer or quotient for this problem, 208. Now, that is similar to, but not the same as, what's considered the traditional algorithm, or in other words, the way your parents probably learned how to do long division. So it's going to look a little different, but it's not so different. So I would use the lines to help me line things up, 1,248. And again, the reason I'm doing that is because it's going to be super important that we have everything lined up correctly, especially when we start to get into dividing with decimals. And then I want to divide by 6. So I'm going to start by saying, and you might even use a piece of paper to help you cover up the parts of the problem you don't need. Does 6 go into 1? No, it doesn't actually go into 1. Does 6 go into 12? Yes, it does. 6 will go into 12. It will go in 2 times. So that's my first step, divide. My second step is multiply. Multiply means to do 2 times 6. So the 2 times 6 is 12. I'm going to put that 12 here underneath and subtract it. So this is This is kind of similar to how we did the other method. We're just putting things in a little bit of a different place. So when I subtract, I'm going to get 0. And that was my next step, was subtracting. My next step is to check. When I check, what I'm checking is to make sure that this number, my answer to the subtraction, is smaller than my divisor. It needs to be smaller than the divisor. If it's not, that means that the divisor could have gone in more times because there was too much left over. And 0 is less than 6, so I'm ready to continue on. And so now I need to do the next step, which is to bring down. Specifically, I need to bring down this 4. And then I'm ready to restart the process. So I'm ready to go back to dividing. And this time what I'm dividing is I'm dividing 6 into 4. 6 goes into 4 0 times. So I'm going to put a 0 here over top of the 4. 6 goes into 0, it goes into 4 0 times. Now I multiply. 0 times 6 is 0. Subtract. 4 minus 0 is 4. Check. Is 4 less than 6? Yes, it is. So now I need to bring down another number. And when I bring that number down, now I have 48. And I want to divide 6 into 48. 6 is going to go into 48 8 times. So I need to write that 8 up here and then multiply. I've divided. Now I need to multiply. 8 times 6 is 48. Subtract. 48 minus 48 is 0. Check. 0 is less than 6. And I would bring down, except there's nothing left to bring down. So my answer is just 208. Now I want you to think about just for a minute and compare that to the big 7 method if you've used that method before. What I want to point out is, just like we had a 2 in the hundreds place in our quotient, we had 2 hundreds. So that's where that 200 comes from, because 6 can go into 1200 2 times, so or 200 times 6 is 1200. 6 could go to 1200 200 times rather, and 200 times 6 is 1200. So that's really kind of what we're doing here. We're just doing it in a different way. And then notice in our big 7, there were no, when I look at my numbers that I'm adding together, there was nothing that was in the tens place. So just like I have a 0 here in the tens place, there's nothing over there that has a digit in the tens place. And I had 8 ones in my quotient, just like I had the number 8 here, 8 ones there. So that's why I end up with the same quotient. Another way that this might have looked that might even make you go, oh my gosh, even more so that it's similar, is if we had done this. Because notice, some of you maybe would have done the big 7 this way. Oops, let me make that a little bit wider. Some of you might have said, oh, it goes in 200 times, and 200 times 6 is 1200, and 1248 minus 1200 is 48, and then 6 goes into 48 8 times. 8 times 6 is 48. This works out evenly. So again, it's really a lot of the same process, just written a different way. Let's look at another problem. Now, for this problem, 735 divided by 21, this is a kind of problem that people who, even if they understand division, kind of go, ugh, because you're using a 2-digit divisor, and maybe we don't know our 21's times tables. But that's okay. We've got some strategies for that. So 735 divided by 21. We want to start by saying, will 21 go into 7? No, it won't. Will 21 go into 73? Yes, it will. But we may not know how many times. That's kind of the big deal with this, is figuring out how many times. So a couple strategies for this. First of all, you could estimate. You could say, well, 21's close to 20, and if I counted by 20s, 20, 40, 60, 80, it's going to go in either 3 or 4 times. And so from there, then you can say, well, 21, you could work out what 21 times 3 is, and 21 times 4, and see which one would work. So we could do it that way. We could also kind of start a repeated addition, 21 plus 21. So 1 times 21 is 21. 21 plus 21 is 42, which would mean 2 times 21 is 42. When I add another 21, now I will have had 3 times 21, which is 63, because I've used 3 21s at that point. 1, 2, 3. That's why I say 3 times 21 is 63. That's maybe big enough, but let's try another 21. If I add another 21, I get 84. So 4 times 21 is 84. That's too big. So I would say, well, 21 is actually going to go into 73 3 times. 3 times 21 is 63, is what I worked out. And 73 minus 63 is 10. Now I need to check. When I check, I see 10 is less than 21, so I'm ready to bring down the 5. And I'm ready to start the process over. Divide, multiply, subtract, check, and bring down. So I'm starting the process over. I need to divide and figure out how many times 21 goes into 105. Well, I know it has to go in at least 1, 2, 3, 4 times. Let's try again and add another 21 and see if it can go in another time. And when I do that, I do in fact see it can go in another time. So it can go in a total of 5 times. And 5 times 21 is 105. And this has worked out evenly. My quotient is 35. Now, a couple of things that are common mistakes that I see people make with something like this. One thing people sometimes do wrong is they do this. They get this part, and they subtract and get 10 and say 21 goes into 10. Oops, let me back up. I didn't make the mistake I was planning to make. So 735 divided by 21. They might do this. They might say 21 goes into 73 twice. 2 times 21 is 42. Subtract and get 31 and say 21 goes into 31 one time. 1 times 21 is 21. We subtract and get 10. Bring down our 5, and 21 goes into 5 times. 25 goes into 105 5 times. Say, hot dog, I'm done. Got it right. Well, the problem is if we went back and checked, remember how we could check? We could check by doing 215 times 21, and we should get 735 if we're correct. Now, probably you should be going, ooh, yeah, no, that's not correct. But look at what we did wrong. When we subtracted right here and got 31, we didn't check to make sure 31 was less than 21, and it wasn't. And that caused us to make a mistake. It caused us to say, well, to start by saying 21 goes into 73 twice, but then wait a minute, it can go in one more time. And that's why we have a 2 and a 1 here. Notice that the 2 and the 1 together make the 3 that we have over here. But you can't do it in 2 separate steps. You have to do them together. All right. Now, another common mistake that I see on this would be something like this. Oops, not 6. I meant to do a 3 up here. Let's see. And 3 times 21 is 63. We subtract and get 10. 21 won't go into 10, so we put a 0. We bring down the 5, and 21 goes into 105 5 times. Now, notice what we did wrong here. What we did wrong, if you listened really carefully, is I divided 21 into 10, and that's where I got that 0 from. But I can't do division again after subtracting until I bring down the next digit. So I couldn't do the division until I bring down the 5. So I would then now be able to do 21 goes into 105 5 times. So I wouldn't have that 0 there in the middle, that extra 0. So sometimes people will accidentally put extra zeros that don't belong. Now, that being said, going back to our original problem, sometimes people will do this. Sometimes people will say, well, instead of putting too many zeros, they might do this. Say 6 goes into 12 twice, work this out. 6 won't go into 4. Let me go ahead and bring down the 8, and it goes into 48 8 times, and 8 times 6 is 48, and it has worked out evenly. Great, great, great. Well, the problem is that you brought down the 4 and the 8 both on the same line, which in and of itself isn't wrong, But what's wrong is if you don't stop before you do and put a 0 to say that 6 went into the 4 0 times, then you brought down the 8 and 6 goes into 48 8 times. So you have to be careful about that as well. So we have to be really careful about adding extra zeros or not putting zeros in where they're supposed to be. All right, let's look at one more problem. There are 417 sixth graders going on the next field trip. Each bus can fit 55 students. How many buses will be needed? If each bus is filled to capacity, how many buses will be completely filled? And then how many would be on the last bus? For this particular problem, this is a division problem, because think about this for a minute. I have 417 kids lined up, all ready to go on a field trip, but they, of course, can't all fit on the same bus, so I put 55 of them on the first bus and wave and say goodbye and send them on their way. Put 55 kids on the next bus, wave, send them on their way. Put 55 kids on the next bus, wave to them, send them on their way. And I keep doing that until I've sent all the kids on the field trip. Well, what I'm doing there is I am doing 417 divided by 55. So let's work out that division. Now, I probably don't know my 55's times tables, but one thing I can do is I could just guess and say, well, what is 55 times 5? I could do 55 plus 55 plus 55 and keep doing that like I did earlier, and that's great. It's also great to make a guess and see if you're correct, and then adjust as necessary. So 5 times 5 is 25, carry the 2. 5 times 5 is 25, plus 2 is 27. That looks a little far away from 417, so I might need to try a bigger number. So 55 will not go into 4 or 41. We're seeing how many times it goes into 417. Maybe I want to try 55 times 7 this time. 7 times 5 is 35. Put down the 5, carry the 3. 7 times 5 is 35, plus 3 is 38. Ooh, that's getting closer, 385. Okay, let me try 55 times 8. 8 times 5 is 40, carry the 4. 8 times 5 is 40, plus 4 is 440. Oh, that's too big. So it's going to be 7 times. So 55 will go into 417 7 times. And I did several guesses to figure out which one would work. So it goes in 7 times. 7 times 55, as we've already figured out, is 385. When I subtract, I'm going to get 11 minus 8 is 3. I'm going to get 32. So I get 7 remainder, 32. Now let's look at that in the context of our question. 7 remainder, 32. So when I do that, how many buses will I need? Well, I can fit 55 into 417 7 whole times and have 32 left over. So think about what that means. It means I could fill up 7 buses and still have 32 kids left over. So I will actually need 8 buses in order to have enough to put that last group of kids that's not a full group on a bus. So how many, if each bus is filled to capacity, how many buses are completely filled? That would be 7 buses that were completely filled. And how many would be on the last bus? Well, I would have 32 students on the last bus. So you've probably learned a variety of ways for doing division, and as long as you can do it consistently, any of them really is okay. I would encourage you to use the standard algorithm that I showed you today, because we're going to soon start dividing decimals, and dividing decimals using the Big 7 method, as you all have probably called it, is really going to be tricky. So it's going to be easier to switch over to using the standard algorithm.